Hello, my friends. Welcome back to CSE 1322. This is lecture number 11, and today we are going to wrap up the object-oriented portion of this class, which is module number 3. So just to orient yourself from where we are time-wise, this is the week of September the 21st, and last week you took test number 1. You will get grades back on test number 1 sometime towards the end of this week or beginning of next. It is still actively being graded. At the point when we post the results for test 1, I will likely post another video at that point and go through the examples from the test and show you how to go do it. I can tell you that I've graded the questions that I'm responsible for, which were the class declaration variable and also the tracing problem at the beginning, and it looked like most of you all did pretty well on those. So hopefully all that will work out. It's just taken us a little bit of time because we do have about 500 of those tests to grade between the different sections. So we're working our way through it, and then we'll analyze everything and make sure that the grades are reasonable across all the sections, and then we will post them. So that'll happen sometimes towards the end of the week, or worst case scenario over the weekend or beginning of next week. So as I say, today we are going to cover object-oriented wrap-up effectively. So I'm going to run through the slides and I'm going to talk through everything that's going on in here, and then I'm going to do an example in both C# and in Java that hopefully wraps together all of the different parts. So without further ado, let me get started on the slides here. So the first thing is, we have talked so far about defining a class, and hopefully that's pretty concrete and clear at this point, where you define your attributes, you define your methods, you have scope for them, where you're public or private or perhaps protected. And then we talked about making subclasses of a parent. And so in a subclass, you inherently inherit, it's weird phrasing, you inherit all of the attributes and all of the methods from the parent that are either public or protected. So that's something that I noticed a bunch on the test that you guys were sometimes struggling with. So I'm just going to point that out. If there is a variable that is defined in a parent, so let's imagine that the parent is a mammal and it's a concrete class and it has a variable called height, which is declared as public. And then you create a dog which inherits from mammal. You don't have to recreate a variable called height inside of dog. It's inherent. You already have that variable. It's there from the parent. So anything that is public or protected in the parent, you immediately have access to it. You don't have to redeclare it. I bring that up because probably about 10% of you in the subclass on the test went through and started redefining some of the things that were already defined in the parent. For attributes, you never have to do that. For methods, you might choose to do that because you might be overriding what the parent does inside of the method. So there we go. All right, so that's the idea of inheritance, and we've certainly covered that. The idea of overriding methods we have talked about as well, and that's where you have a parent and you are in a child class, and you may want the child to do something more specific than the parent does in whatever that method is. So you would override the method, which is different than overloading the method. Overriding the method specifically only happens inside of inheritance. You have a parent, you have a child. The child might choose to override one of the methods from the parent. Overloading a method means that you have more than one definition for the method, same name of the method, but different parameters that are coming in. That's an overload. And just make sure you keep those two straight because that's important. We talked about an abstract class, and this is a class where you cannot instantiate it. It is meant to be a general idea, and then people can instantiate, or people can inherit from that, and then the inherited classes can be instantiated. An abstract class can have a mix of methods that are concrete, where there's actually a definition, or they're just a header. Typically, there will be at least one abstract method inside of an abstract class, otherwise it's really not abstract. An interface is a completely abstract class, meaning that there is no implementation allowed inside of an interface, and it also cannot be instantiated. Interfaces are simply there to allow a definition of what somebody would have to implement in order to actually use that interface. The cool thing about interfaces is that you can effectively inherit, but in this case the word is implement, more than one interface. We talked about polymorphism, where you can start off with the example that we covered before, and we're going to cover again, is you could have a mammal parent, and then you can have dogs and cats, which are children of that class. And in polymorphism, you might have a reason to instantiate an object as a mammal, but then have a new dog assigned to it or a new cat assigned to it. And that is polymorphism, where it is a mammal, but at some points it looks like a dog, and at some points it may look like a cat. And we're going to look at a problem that comes up with that today with regard to casting. So that's going to be one of today's topics. And then the last thing on here is array lists, which we've definitely talked ad nauseum about, I think. All right, so we're going to go back to our tried and true example here. So we have a parent, and we're going to use the mammal one again because it's one that we're familiar with. In this case, this could be an abstract class because, again, we know that mammals are not a thing in the real world. So it's a concept, it's an idea of what all of these mammals will need to have and some of the things that they have in common. So, for example, all mammals breathe. So we could definitely say in the abstract definition that a public method called breathe is going to be necessary. And then if the cat does something very specific to breathe when it inherits from this mammal, then it can certainly override breathe if it needs to. If it doesn't, then it'll just inherit it. So in the case of the dog, which also inherits from mammal here, we don't have an override for breed. So whatever the rule for breathing is for a mammal, the dog has inherited it without having to do anything different. And again, we can tell that this is a public because of this plus sign. So remember in the UML diagrams, minus signs are private, plus signs are public. So all right, so we have our mammal, which is an abstract class, and then we have a dog and a cat, which both inherit from mammal. The dog has a method called talk and a method called do dog stuff, which we won't talk about. The cat has a override for breed. And then in this example, we also have this other class over here, which is an interface. And this interface is called talkable, or italkable would be how it would typically be labeled. So that has one method, talk. So in order for any class to implement this interface, they must have a talk method. So in this case, our dog has a talk method, which is overriding this interface over here. All right, so that's the UML diagram, and hopefully by now you guys are getting pretty used to the UML diagrams. It is important that you can read them. We do know that from the labs that you guys are doing, so IntelliJ does have the ability to produce these diagrams for you, and so hopefully you've gotten used to doing that and being able to see them. You can also just draw them. These were just drawn with boxes. There's nothing magical about UML diagrams. Okay, so let's take a look at that exact example, but this time we're going to look at it in Java, and then we're going to look at it in C++. C#. All right, so we begin with this abstract class for mammal. And again, it is abstract because there is nothing in here that's actually going to be, there would be at least one thing that is abstract about this class. In this case, we're actually implementing breathe as just printing out a print line. So as an abstract class, this is kind of weird because we actually did implement everything, but it is declared abstract, which means that you cannot instantiate a mammal. All right. So then we have an interface down here, which is talkable, and it says that there has to be at least one method and it has to be talk. You must declare a method called talk. Then we have our dog. Our dog extends mammal, which means that it is inheriting from mammal, and it also implements talkable. Now, I don't think we've seen an example where you can do both of those on a single line, but that's exactly how you would do it in Java. The keyword for inheritance is extends. You're extending mammal, and there can only be one class there. But then the keyword for implementing an interface is implements, and there can be more than one here. You can implement more than one interface in any one method, or in any one class, sorry. So this class dog has two methods. One is talk, which is the implementation of this interface talk method. And then the other one is do dog stuff, which says wolf. And then we have our cat, which does breathing, which says I have kitten breath. Yeah, it's kind of a weird example. We're just going to go with it. What is kitten breath? Anyway, we're not going to talk about that. Moving on. So again, we have an extends here. That's the syntax in Java. We're extending mammal because we are inheriting from it. And we have our breathe method. Let's take a look at the same code in C#. Pretty much the same thing. We have our abstract class mammal. We have our method in there for breathe, which is the same. We have our interface, which is talkable, and then we have our dog. So really the only syntax difference I think in these slides, other than the console.write lines and the system.print lines, are this. So in C#, you're declaring the name of the class, which is dog, and then you simply have a colon. And then this is slightly weird. We're listing something that we're inheriting from or implementing and something that we are implementing. And we're just listing them with a comma separating them. So in C#, only one of these can be an abstract class. All the rest have to be interfaces. Only one of these can be an abstract class or a concrete class. All the rest of them have to be interfaces. So if you have more than one in the line, everything has to be an interface except for one. One thing can be the abstract or the concrete class. All right, so I'm just going to flip back and forth between these two and see if anything else changed. Yeah, it looks like up here we have to very specifically say that that's public, but I think that would have been good to say in Java anyway. And other than that, I think it is just the extends and the colon. So yeah, all is well here. So hopefully that makes sense to you guys. So I'm going to flip back and leave this on the other screen, and I'm going to look off to the side where I have another copy of these slides running on another computer so that I can ask you these questions, but you can be looking at the thing that you want to be looking at, which is the code. All right, so the first question is, if I were to say cat C1 gets new cat, is that allowable? So to be clear, I'm instantiating cat as C1, which is the name of my variable, and I'm saying gets new cat. So yes, that is completely plausible. It's plausible because this is a concrete class. There's nothing about it that's abstract, so I'm allowed to instantiate it. And my syntax was cat C1 gets new cat, and that is absolutely allowed. I'm creating a variable, an object of class cat, and an object of type cat, and I'm giving it a new cat, which is completely plausible. That's exactly how you instantiate an object. All right, likewise, dog D1 gets new dog. Yep, absolutely, that's no problem. Dogs are concrete, so dog D1 gets new dog, not an issue at all. All right, can you do the weird ones? So can we say dog D2 gets new cat? Okay, so let's go back and look at these. Dog D2 gets new cat. So there's no actual relationship between cat and dog other than that they both inherit from mammal. So you cannot instantiate an object of type dog, but then say gets new cat. That's not allowed because they are not in any way related directly at this level. They are related simply because they share a parent, but they're not related in a way that you can instantiate one on top of the other. So dog D2 gets new cat, absolutely not allowed. Likewise, the reverse of that, cat C2 gets new dog. This is not that kind of world. You can't instantiate a dog on top of a cat. So no, these last two do not work. All right, so let's take a look at this. So can I create a type talkable T1 gets new dog? So let's look at talkable. Talkable was my interface over here. So I said talkable gets new dog. Is that allowed? And the answer is yes. The type can be talkable because my dog implements talkable. So I can have an object of type talkable which has a dog running on it. So I have an object, which in this case is called T1, and T1 is allowed to have a dog instantiated on it because there is a relationship. It implemented the interface. All right, so let's take a look at the next one. Talkable T2 gets new cat. Am I allowed to make a new cat? Well, the answer here is no, because cat does not implement talkable. So I'm not allowed to use this as the type of variable when creating a cat because there's no relationship. There is a relationship here. There is no relationship here between talkable and cat. Okay, so that one is not allowed. All right, let's look at the next one. Mammal M1 gets new mammal. Okay, so can I instantiate a mammal? And the answer to that is no, because I declared mammal as being abstract. The moment I declared it as abstract, I cannot create objects of that class. So this will not work. Mammal M1 gets new mammal, not allowed. All right, let's look at the next one. Mammal M2 gets a new dog. Okay, so the type is going to be mammal, but I'm sticking a dog on top of there. Is that allowed? And the answer is yes. Mammal, as the type, the dog inherits or extends mammal, so therefore dog is a permissible thing on top of mammal. So I can absolutely have a variable that is of type mammal called M2 and give it a new dog. Likewise, I can give it a new cat because of the same exact reason. Both cat and dog inherit from mammal. So therefore, I am allowed to create those. A cat is a mammal, a dog is a mammal, therefore I am allowed to make a mammal and put a new cat on there. That's polymorphism in both of these cases. Because I have a base type and I'm putting a concrete subclass on top of it. This is also polymorphism up here. All right, so now we're going to take a look at the next one. Cat C3 gets new mammal. Is that allowed? Okay, so the answer to that is no. I can't have something that is of type cat, but then try to instantiate a mammal on it. Well, the first problem is I can't instantiate mammals, so that's not allowed. But even if this were not abstract, I still couldn't do it because that's not the way the relationship goes. A cat is a mammal, but a mammal is not a cat. So you can only go the direction of the inheritance. All right? Okay, so let's take a look at these next two. So mammal M2 dot breathe. So M2 was a dog. So we said mammal M2 breathe. So let's take a look at what's going to happen there. So we created M2 of type mammal, and we put a new dog on top of it, and we called the method breathe on M2. Well, since there isn't a local definition for breathe here, we're just going to inherit the breathe from the mammal. So this is perfectly allowable. M2 is allowed to breathe. The dog is allowed to breathe. And what's going to happen is we're going to get right line generic breathing. And that's because it is going to call the parent. So life is good there. All right, let's look at M3. M3 was given a new cat, and now we're calling M3.breathe. All right, so cat inherits from mammal, but cat overrode breed. So therefore, breathe is going to happen from the cat's class, not from the mammal's class. There are two different possibilities, but since we overrode it, the local version is going to fire. So in this case, you're going to get, I have kitten breath. All right. The last, hopefully all of those were helpful and they all hopefully make sense to you at this point. It's very, very important that you understand everything on this slide as to why they do and do not work. So you may want to go back through that again. You also might want to just test yourself by hiding that on the right-hand side of the screen and seeing if you come up with the same answers going through them again as to whether they're allowable or not. All right, the last one is going to bring us to our problem of the day. So I'm calling M2, which you will remember is a dog sitting on top of a mammal, so M2.talk. So M2 down here of dog, I'm calling talk, but I'm calling it on a variable of type mammal. So the problem here is it's going to look up in here to see if there is a talk, because that is the type of the variable. It is a mammal. M2 is declared as a mammal. So it's going to look in mammal for a talk. It does not find one. So there is an override talk that is down in dog. And you might say, well, then shouldn't that just fire? But the problem is you declared it to not be a dog, you declared it to be a mammal. And once you declare it to be a mammal, it starts looking up here for the actual variable, or the method. In this case, the method talk does not exist in mammal, so you're going to get an error. And that's very confusing to most people, because you have a talk down here in dog, and you're saying, but I made a new dog, why can't the dog talk? And the answer is because the dog is of type mammal, not of type dog. It's this that's getting you. Had you said dog M2 gets new dog, yeah, absolutely, you can call talk. So in order for this to work, we're going to have to do a cast. And that's the topic that we're going to cover next. So before I talk about what's on the screen, let's talk in general about what a cast is. Anytime that you have a variable inside of Java or C#, it's the same problem in both cases. And you want that variable to behave like something other than what it is, you're going to have to cast it. There are a couple of times where both languages will do automatic casting for you because sometimes it's relatively obvious as to what you mean. So let's take an example. If I say that a variable is a float, or a double, and I say, okay, it has the value 7. Well, I've declared it to be a float, but what I actually gave it was an integer. So it's easily understandable that if I then assign that to an integer, you could figure out what it is that I mean by that. I probably meant for you to give me an integer 7. But it's a little bit weird as to what happens if I gave you 7.5 and then I assign it to a variable that is an integer. So I have a double, it is 7.5, and I assign it to an integer. And I'm just going to do that so that I'm not talking abstractly. So I'm going to say double. No, I'm not. I'm going to turn on my pen first, and then I'm going to say double. So I'm going to say double x equals 7.5. There's a point in there. And then I'm going to say int y equals x. So what is it that I expect this to do? Because it's not really clear what I intended to do here. Maybe I meant for it to give me 7. Maybe I meant for it to give me 8, because if you round it, you would actually end up with 8. It's not really clear. So let's go to a window and let's ask some REPL to do this for me. So I appear to be in C# at the moment, so I said, what did I do? Float or double? I said double. Double x equals 7.5, int y equals x, and then let's print out y. So what does the compiler do with that? It says, I don't know what you're asking for here. It's ambiguous. It's not clear what you wanted me to do as a compiler, so I'm just not going to do it. I'm going to protest, and I'm going to make you actually tell me what you wanted here. Because there are 2 valid answers. One valid answer is 7, one valid answer is 8. It just depends on whether you're rounding or not. And what is the default? Do you want it to round? If you've ever watched one of the old Superman movies, you know that rounding money is probably not a grand idea sometimes because, well, there's fractions of pennies that get thrown away, and who knows what you meant to do with those fractions of pennies. Stock them away and take over the world, obviously. So how do you get around this? Well, what you can do is you can put a cast in here. So what I did was I just put the word int on front of x. So what I'm doing is I'm asking it to cast the value directly into an integer. Now the rule is, if you ask it to cast from a double into an integer, it's just going to truncate everything after the period, which is not probably what you want. So this is probably not the right answer, but it does illustrate a point, which is if you need a variable to behave like some other type other than what it is currently listed as, and you want to believe that it has automatic rules for what to do with that conversion from one type to another, then you can use a cast. A cast is simply, in parentheses, ahead of the variable, you specify what type you want it to be read in as. So for example, if I change this to a float, and I change this to a float, and I do the compile again, I'm now asking it to convert a double into a float. And that's perfectly acceptable, and you can see that it gives me 7.5. So there are a few places where it will automatically do this for you, and those are called automatic up casts and down casts, depending on which direction it's going, from a very specific to a less specific, or from a very less specific to a more specific. They're rare, and you probably should never rely on them. Most of the time, the compiler is just going to tell you, no, I'm not going to do this. You have to be explicit as to what you want. So you need to get in the habit of sometimes you're going to have to specify a cast to tell it to do one thing or another. So what does all this have to do with our objects? And very specifically, what does this have to do with our dogs and our mammals? Well, the problem down here is you have a variable m2, which you have declared to be of type mammal, but it actually is a dog because of polymorphism. So when you try to call talk on it, it's trying to call talk on a mammal, but really what you want it to do is call talk on a dog. You're not changing the object to be of type dog. It's just that right now, for this one specific thing, so I can make him bark, I want to make him into a dog. And that's done with a cast. So that's what's going on over here. So m2, which is the name of my variable, which is declared as a mammal, is being cast to a dog, and then the resulting thing is being asked to talk. So it is calling the method talk on the resulting m2 cast to a dog. There's a little bit of if statement above this, and you'll see why. The if statement is not important for right now. The thing I need you to understand right now is that you are casting an object which is of type mammal into an object of type dog for this one statement only. It does not change the dog, it does not change M2, it does not change mammal. It only, for this one very specific statement, converts the type from mammal to dog, because that's what I asked it to do. Once this is a dog, it clearly has a talk method, and now it is happily going to let you run that. So that is a cast, and in this case, it is a runtime circumstance that this is going to happen, because with polymorphism, we know that a mammal can get a new dog or a new cat at any time during the code. And so I may need to, at moments, think of it like a dog, and at moments think of it like a cat. I will point out that you cannot cast something completely bizarrely. So like, for example, if I go back to my little REPL window here, I can't just magically say this is, well, I might actually, can I say string? I don't know if I can say string. Well, it would be especially helpful if I did the right kind of string. Which language am I in again? No, I wasn't the right language. It's a lowercase string. So no, I cannot, and it's because there is no rule for how to do that. Which language am I in? This is C#. All right. In C#, we would need string to be a string is a lowercase. That is the correct type. All right. So no, it does not allow me to do that. And my point here is the cast is only valid if it is plausible. If there's a polymorphic relationship between the two, it is plausible. So with our case of our mammal and our dog, you absolutely can cast to dog instead of being mammal. But you cannot just magically cast to cat as a type. So you can't say mammal M2 gets new dog and then cast that to a cat. That's not possible. You can cast it up, but you can't cast sideways to some other thing that happened to inherit. All right, so hopefully that makes sense. So there's two other things that are syntactically interesting on this slide. So that was our cast, and if you are a C# student, in a lab about 2 weeks ago when we were dealing with the light bulbs, you were having to call pull string on the light bulbs. I think that was a lab or an assignment. You actually had to do a cast in that in order to get it work back then as well. And that's because when you stick things into an array list, in Java, you specify the type of the array list, but in C# you don't. In C# it just takes objects. And the problem is when you put things into something that just takes objects, they're all treated like object. So when you then try to call a method on it, it won't work. You actually have to cast it back to whatever it was in order to be able to use it. So that's another example of where you would have to use a cast. All right, so the last syntactical thing that's going on here is this instance of or is option down here. These are Boolean evaluators that tell you which type something is from a polymorphic standpoint. So M2, is it an instance of dog? If it is, then you're going to do this. If it isn't, then maybe you want to do something else, like maybe you want to cast it to a cat if it's an instance of cat, or you might want to cast it to turtle if it's an instance of turtle, or whatever it is. So instance of is a keyword that can be used inside of an if statement to tell you whether or not something is of this class type. The equivalent in C# is, so M2 is dog is either true or false. So it's kind of like is but it's just is. All right, and then that allows you to very specifically cast it to the right thing that you might want. All right, so there's a weirdness here, is that in some languages, the casting may have a different priority to the period, which tells it to actually call a method. So you should always get in the habit of putting parentheses around the thing that you're casting to be very explicit that you want the cast to happen first, and then you want the method call to happen. I know we're not talking about C++, but you're probably going to have to take that class in the future. If you're in C++ and you do this, it will actually attempt to call talk first, and then it will do the cast at the end, which is not at all what you want. So In all languages, it is better to just put the parentheses around it and make it explicit as to what you're trying to do. I want this cast to happen, and then I want this. It's like an order of precedence with numbers when you're doing math. All right, so M2, cast to a dog, is now treated as a dog for the purposes of this statement. And now you can call talk or any other doggy method, like do stuff. Do doggy stuff? I think it was something like that. Okay, so we're going to make an array list here, and we're going to make the array list in Java of type mammals. We're going to do this again in C# in just a second, so hang on there, C#, folks. But it's good to understand it in both directions. So we have a list here in Java of type mammal, and we are going to give it a new array list, and then we're going to start adding things in there. We're going to add in a cat, and we're going to add in a dog. All right, now the first thing to notice is I declared that my list, or my array list, is going to be of type mammal. But then what I stuck in there was a new dog. So that's valid because a dog is a mammal, and you said these are going to be a list of mammals. I gave you a dog is a mammal, life is good. This absolutely will compile and will work. It is not a problem. Then I'm able to stick a new cat in there, and I'm going to say new cat. Boom. So we have Fido and Fluffy in here, and they are happily living in an array list that is declared as being of type mammal. All is good. It is inherently polymorphic. I need you to realize that straight away, because I am using new on a subclass, not on the actual class that is the type of the structure. All right? So now I'm going to do an iterator, and we've seen the for each loop before, so I'm going to say for each mammal, M, in animals, which is my happy little array list up here, I'm going to say m.breathe. And that's going to work no matter what, because mammal, if we go back to it, mammal has a method called breathe. So I am happily able to call mammal breathe, and if there is no matter what, I will get an output. When I try to do dog stuff or talk, that's when I'm going to have to do my casting. So what we're doing here is if M is an instance of dog, then I'm going to cast M to a dog and do dog stuff. If M is an instance of talkable, then I'm going to cast it to talkable and do talk. And that is just to point out that you can do checking to see if it is an interface or if it is an abstract class or a concrete class that it is a type of from inheritance. All right, we're going to take a look at that same code in C#. So again, up here we have list. I will point out on the last slide, I said this is an array list. In actuality, an array list is a specific type of list in both languages. So in C#, if we use a list here, then we still have this mammal capability. If you just do array list, it is of type object. It is not of a specific type. It's not a generic, which we'll talk about later. All right, so animals, add a dog, add a cat, and then we have the exact same syntax down here, or sorry, the exact same methods going on down here. The syntax is slightly different. So this was a for statement. Now it's going to be for each mammal M in animals, and animals again is our list. M.breathe works because again, mammals all know how to breathe, but M.do dog stuff would not work because mammals do not all do dog stuff. In order for that to be plausible, I have to cast M to a dog and then call do dog stuff. So if M is a dog, do dog stuff. If M is talkable, then do talk. All right? So hopefully that makes sense to you. So to be clear, everything that was in that list was a mammal. They were not cats, they were not dogs, they were mammals. The particular objects that I happened to stick in there were of type dog or of type cat. But they are all still mammals because a dog is a mammal and a cat is a mammal. When you pull something out of the list, what you're pulling out is a mammal because that's what you put into the list, mammals. Since there's no such thing as a mammal, you're going to have to see what it is that you have with the is or instance of, cast it to the appropriate type, and then call the method that you were trying to call on that object. So hopefully that clears things up. This example is comprehensive. It covers everything that we have covered in Module 3. You have classes, you have abstract classes, you have concrete classes, you have interfaces, you have inheritance and implementation of interfaces, you have polymorphism, and finally you have casting. If everything that I just showed you there makes sense to you, you are in good shape when it comes to object-oriented programming concepts. I'm going to do another example, which I'm going to code with you here in the next couple of minutes, just so that you have yet one more example. But if you understand what we just covered and you understand what I'm about to cover, then you are good to go on object-oriented. If you don't, you really need to keep going back and re-looking at these slide presentations that I've been recording for you, or ask questions. If it's still not making sense, you need to ask questions. So without further ado, I'm going to switch over to a window and I'm going to start coding a couple of these examples. So the first thing I'm going to do is I'm going to get rid of all of this so that I don't start off in some messed up place, and make sure that that compiles again. And I get well, it's going to complain that y doesn't exist. Yes, of course. All right, do I get a hello? I should get a hello. Okay, so what we're going to do is we're going to talk about phones, and I'm going to draw you a quick UML diagram to talk about our example here. So a phone, as you know, is a thing, and there are two examples of it in the real world that we are most familiar with. So we have cell phones, and for those of you who are over the age of 10, there was this amazing thing called landlines. I joke. You probably still have a landline. Maybe. Probably not. I have a landline sitting next to me in my office here. Nobody ever calls me on it. That's not true. I do get spam calls every now and again. But anyway, so landlines. Yay. Most people nowadays think of a phone as a cell phone, but there are other examples of that. All right. So what kinds of things do a phone have? And I'm just going to, again, look over to the left every now and again because I have this example and I want to make sure I'm doing the right thing. So it's going to have a phone number, because all phones have phone numbers, whether they're landlines or whether they're cell phones. There's also this concept of a phone call, and both landlines and cell phones have the ability to make phone calls. But there are other things that can make phone calls. Fax machines make phone calls, for example. Everyone's thinking, what's a fax machine? But anyway, go look it up, kids. They're on Wikipedia, I'm sure. All right, so over here, we're going to create an interface, and we're going to call it phone call. And an interface has a P. Good Lord. All right. It is a lot of fun writing on a touchscreen, just in case you've ever tried to do that. All right. So where is that button? We're going to call this iPhone call because it is an interface. And phone calls have two methods. They know how to place call, and they know how to receive call. All right, so there's two directions of calls. You can place an outgoing call or you can receive an incoming call. All right, so our cell phones, our landlines, and our phones have relationships to each other. So it is clearly the case that a cell phone is a phone. I think everybody can understand that one. So there's going to be an inheritance there. A landline is also a phone. You're just going to have to take my word on that one. And both landlines and cell phones are going to implement phone call, because they both have the ability to implement phone call. These are supposedly dashed lines. I don't know how to draw a dashed line. I'm sorry, folks. There you go. It's kind of dashed. See? There you go. Perfect. So what attributes are we going to have for each of our phones? I'm going to give this a nickname because I may have more than one cell phone. And I'm going to give my landlines a location because I may have more than one landline. I have a home phone number and I have an office phone number. And for a cell phone, I may have my primary cell phone and I may have a work cell phone, or a burner phone, I guess, if you're that kind of person. I don't know. Anyway, moving on. And then they're both going to have phone numbers. But you can see that I already have a phone number defined up here in phone. So I want to point out that it is not necessary, and not only is it not necessary, it is wrong to redefine that attribute down here, because there's no need for it. You've already defined it. You need to be careful that when you're writing code in object-oriented, that you're not reinventing the wheel just for the sake of reinventing the wheel. The whole point of all of this crazy that we've been going through for the last couple of weeks is so that you realize that you don't have to keep rewriting things, and it is wrong to rewrite things because you are more likely to break something when you do that. The code that you're inheriting in most cases has been heavily debugged and tested. That's the whole point. So if you're implementing somebody's API, the hope is that they've already tested that API inside and out, and all you're doing is inheriting it and using it. You don't have to rewrite what they gave you. They have already tested it and made sure that that part works. So just use it, don't rewrite it. So again, don't have to redeclare the phone number in both of these cases. All right, so we are going to eventually have to implement place call and receive call in both of my cell phones and landlines. Those are both going to have to be written. Why? Because iPhone call is going to be an interface. That's why I put an I on the front of it. So I'm going to have to implement them if I want to be able to do phone calls. You might also have another interface for web browsing and another interface for email, and the cell phone could conceivably also inherit, or very specifically implement, both of those as well. Because cell phones have the ability to do phone calls and text messages and email and web browsing and a bunch of other things. Landlines only have the ability to do cell phone or to do calls. Typically, I guess you could have a landline that has crazy extra features, but generally landlines just do calls. So it's plausible that there's a bunch of other statements off here to the side where there would be other interfaces that the cell phone also implements. I'm not going to deal with them in this example, but you can understand why that might be true. Because again, it is the case that you can implement more than one interface. And cell phones in the real world do implement more than one interface. They not only know how to do calls, they also know web browsing and text messages and a bunch of other stuff. Okay, so enough jibber jabber. Let's start off in C# for the fun of things, because I usually start off on the other side, and I'm just going to do it in C# first, and then we'll work backwards. All right, so the first thing I'm going to do is I'm going to define my interface for iPhone call. And my interface is going to need place call, which is going to take in a number. It probably needs to be a long, because, well, phone numbers turn out to be very long integers, or very long numbers. And it could return a void, or it could return how many minutes, or who knows, but it'll have some kind of return value. All right. And then I'm also going to have, we'll assume this one returns how many minutes it ran for as well, receive call, which doesn't take in any parameters because it just receives a call. So that's my interface for iPhone call. Please note I did not implement any of that because I am an interface. Therefore, I just say there will be these two methods. Anybody who tries to implement iPhone call must implement place call and receive call. Those are the two required things that they're going to need. All right, so let's start off with my phone. So this is going to be abstract because you are either going to instantiate a cell phone or you're going to instantiate a landline. You're not just going to instantiate phone. All right, so we're going to have an abstract class phone, and it is going to have two things. We're going to say it has a public long phone number, and we're going to say it has a public string manufacturer. All right, now, yeah, landlines, who makes them? Who knows? We're going to say AT&T. They're the only people who ever made landlines, I think. I'm sure that's not true. All right, so now we're going to go ahead and start actually creating the concrete classes. So far we've made an interface, which I can't instantiate, and we've made an abstract class, which I can't instantiate. If I try to do either of those things down here, it is simply going to bark at me and say, the heck are you doing? That is not valid. Cannot create an instance of the abstract class or interface iPhone call. Even if I change this to phone and say new phone, it's still going to bark at me because I'm trying to do something that I specifically cannot do. It's an abstract class. You're not allowed to do that. So all of that is a bucket of nonsense, and you're not allowed to do that. Cool. So let's actually make something that we can instantiate. Let's start defining how a cell phone works. So we're going to have class cell phone. And I'm going to say that it inherits from phone, or extends phone if we're in Java, but here we're going to have a colon. But I'm also going to implement iPhone call. And again, this is that weird syntax where I'm just listing two different things, and it knows that this one is an extend and this one is an implement, because in C# there is no distinction in syntax between the two of those. They're both done with a colon. All right, so I'm going to have my nickname in here. So I'm going to say string, if I can type, string nickname. and I'm going to have some constructors because we need to be able to construct our cell phone. So we're going to say public cell phone. Ugh. Isn't it great watching me type? I'm sure you always love watching this. And we're going to have to set a phone number. What is it? Yep. We're going to say my phone number is 441234567. It's not really my phone number. And then we're going to say nickname. If you don't give me a nickname, then I'm going to assume it is just generically called cell phone. Cool. All right, let's make a more useful constructor, which takes in a nickname. And in this case, we are going to say nickname gets new name. Cool. And I guess we need to set the phone number as well. I'll just copy and paste this because that's easier and slightly faster. All right. So life is good. We have constructors. Now, in order for this to work, if I try to compile this right now, I'm going to get an error. And the error that I'm going to get is I am implementing an interface and I haven't actually done it. Cell phone does not implement interface member iPhone call place call. Cell phone does not implement interface member iPhone call receive call. I declared this is an interface. I said I'm going to implement the interface and then I did not do it. Bad coder. So now we actually have to write both of those methods in a concrete way. So I'm going to return, these are both going to be public, and I'm going to return, I'm going to make the first one called place call, and you can tell that it's already giving me that as a automatic fill because it realizes that I'm going to have to do that, which is kind of awesome. And we said this is going to take in a long phone number. So we'll just call it num. All right. So place call, we're simply going to just print out that I've made a call. Obviously, in the real world, you'd have to implement all the wonders that are making a phone call, which there's a lot going on there, but let's just pretend like that all makes sense. Yeah, so cell phones actually have to figure out what cell tower they're next to, and then they actually have to negotiate with the cell tower. They have to exchange time. They have to make sure that they're in sync. They have to calculate which cell tower is closest to them at the moment. The cell towers have to sometimes hand the call off to the next one as you're driving down the road. There's a whole lot going on when you're making a cell phone call and you're driving down the road. But none of those details matter to us. In our happy world, we are just printing out the words, making a call on a cell phone. Called, and I'll go ahead and print out the nickname just so that we get something useful out of here. I said that this is going to return an integer of how many minutes? 10 minutes. Sound good to you? Sounds good to me. The details of the phone call are not what's important. What's important is that you're getting the inheritance and the implementation. That's what we're really trying to learn here. All right, so the other thing I said that we were going to have is receive call. So that's going to be pretty much the same exact code. As a matter of fact, it is so much the same code. I'm just going to copy and paste so that you don't have to watch me try typing. Yeah. Receive call, this one doesn't take in any parameters because that's what I originally said. And it says, yeah, ring, phone is ringing. That is not ringing. And then in this case, we're also returning 10 because that makes sense. Okay, so we have now created place call and receive call, which were the two things that the interface said that I was going to implement. So let's ask the compiler to compile this, and hopefully this time the compiler will be a little bit happier with me. The compiler has gone home, apparently. If you're using REPL, this is the clear button, just in case you ever need to do that. Hey, life is good. So the only complaint it has is that phone manufacturer is never assigned to and will always be given its default value of null. So yeah, I declared that there was going to be a manufacturer up here, but then I never actually used it. So all right, you could fix that by putting that in the constructor. I don't care. It's a warning, which warnings are okay, errors are not. It's just telling you, I don't know if you know what you're doing here, but well, there you go. All right, let's declare our landline. So we're going to have another class, landline. This one is going to inherit from phone and implement iPhone call, just like our cell phone did. I'm going to be consistent with where I put my curly braces. There we go. And it's going to have a string, location, and then it is going to have a constructor. And we're going to do the same thing. We're going to say location equals landline, which makes no sense whatsoever, but there you go. And we're going to give it a phone number. Phone numbers are great. And then we're going to have a more useful constructor. This is an overloaded constructor because now we're taking in a parameter. This time it's going to be the new location. I'm being terribly inconsistent with how I'm doing my variable names, and I apologize for that. Either do all underscores in between the words or don't. Don't do it sometimes and not do it all the times. Doesn't really matter which convention you go with, just go with a convention and do it. Anyway, all right, so in our overloaded constructor, I need to set location equals to our new location, and I need to set the phone number, which I'll do in the same location, and again. Great, phone number is set. We have our constructors, and now because we are a implementation of iPhone call, I have to, because I said I was going to, I have to implement place call, which takes in my int, takes in the long, which is the number that is calling. I'll just call it num, and then it does the wonderful thing of printing out the location. All right, and we are returning 10 because all phone calls take 10 minutes, and then we also have the need to declare receive call, which I'm again going to copy and paste just to save you time, and that is receive call. It doesn't take in a parameter, and we are ring. Not cell phone. All right, landline's ringing in location compile, and it's telling me that I have an error with regard to location, which I would totally have said that I defined location as being up at the top. I did, with a capital L. See, this is what happens when you're inconsistent. Batted. Okay, life is good, everything compiles. So, I have done what was going on in the slides. I declared an interface, I declared an abstract class that is the parent, I declared two children, both of which inherit from the abstract class and also implement the interface, and they have all of their various methods. So now let's jump down to our main, and inside of our main, we're going to do an array list of phones, because we can. So we have array list, we're going to call it my phones, and that's going to get a new array list. And in order for that to work, I have to include collections. Using, what is it, system.collections, yeah. Don't do that, you're going to get a compile error. All right, so cool. So we have my array list, and I'm going to start sticking a few phones in there. So that is not how you spell array list. There you go. And that's missing a semicolon. Okay, so we are going to say my phones dot add, and we're going to give it a new cell phone. This one is going to be called personal phone. Personal cell. How about that? All right, my phones add new cell phone work cell. Cool. And then we're going to make a landline. All right, life is good. We have 4 phones. 3 phones, I can count. So now, let's try some stuff. So we should be able to say, well, let's make a loop. Let's make them all ring. How's that sound? So what we're going to do is we're going to do a for loop. So for each phone, because they are all phones, We're going to call it a phone as we go through the loop. In my phones, what I'm going to do is I'm going to call a phone dot receive call. All right, is life going to be good? The answer is no. No, it is not going to be good. Why is it not going to be good? Because phone, which is what I declared a phone as being, phone does not contain a definition for receive call. Let's go look. Phone indeed has no method for receive call. So I cannot just receive call up there, and it even tells you you're probably doing something weird here. There's no extension receive call of type phone. Sometimes it actually says, are you missing a cast? In this case, it said, are you missing a reference? So we're going to have to cast this guy. So what are we going to cast it to? Well, I could say cell phone. And remember, you need to put a set of parentheses around that to be absolutely sure that it understands what you want. Now are we good? The answer is no. It's going to work for the first two. Indeed, I got ring ring, phone is ringing on personal cell, ring ring, phone is ringing on work cell, which are the first two. Why did it not work on this one? Well, because the specified cast is not valid. I asked it to cast, so let's talk about what we have here. We have an array list, which is in C#, it has no type. They're just all objects. One of the things that I stuck in here is a landline. So when I get down below in my for each, I get to the landline and I say cast the landline to a cell phone. And it says, do what now? There's no relationship between landline and cell phone that it can make a cast. That is not a thing. So here's my landline. It is extending phone and it is implementing iPhone call, the same as my cell phone, but there is no relationship between landline and cell phone. Think of them as brothers or sisters. They cannot just magically become each other. They may have the same parent, but you can't just suddenly say, Sue, you're now Jane. It's not how that works. So this is not valid because I am trying to cast this third thing, which is of type landline, into a cell phone. So how do I get around this? Well, I need an if statement. So I'm going to say if a phone is cell phone, then do that cast. Now that makes a lot more sense. Now I can just stick an else on here, and there we go. Else if a phone is landline, landline, then we are going to cast the same general idea, but instead of casting it to cell phone, we're going to cast it to landline. That is very annoying that it did that. Landline. All right, now is it going to work? And the answer is, unless I missed a semicolon somewhere, which is entirely possible, yes, it is going to work. We're waiting on the compiler. It hasn't actually done anything yet. Still waiting on the compiler. All right, we'll go ahead. Oh, there it is. Yay! Ring ring, phone is ringing on personal cell. Ring ring, phone is ringing on work cell. Ring ring, landline is ringing in home. Okay, so let's be clear. We created an array list, which in C# has no type. They are all just objects. We then added in something that was a cell phone, and then we added in something that was a cell phone, and then we added in something that was a landline. And then I iterated through those, and I asked each of them to receive a call. I had to do a cast because when they pop out, they are all just of type object, and object does not know how to receive call, so I have to cast it to whatever particular type I actually mean it to be, which in this case is cell phone. They came out as phones because I declared them as being phones. If I change this to cell phone and I only deal with the first two, then life would be good. If I change that to landline and I only deal with the last one, life would be good. But since I mixed it, life is not good. All right. So converting all of this code over to Java, I am going to head over to the Java window here. And I mean, honestly, not much of this really changes. We just have to change around a couple of the types. So I'm going to have my iPhone call.java. I'm going to eventually have a phone.java, which is going to be my phone class, cellphone.java, And we're also going to have landline.java. Cool. Those are the ones that I'm going to have. All right, so we're going to copy and paste, and then we're just going to fix. So the interface for iPhone call, not iPhone, it's a very different thing. That is pretty much going to work as is. I don't think I have to change anything there. For my phone class, I think that's pretty much going to work as well. I don't think I'm going to have to do anything with that. Yes, I am. String has a capital letter. All right. And now we're going to come down to our cell phone. I'm going to grab that guy. There he is. And we're going to stick that in here. And I change that word to extends, take away that comma, and I say implements. And I change that to a capital S. And I change that to a capital S. And I change that to system out print line. I'll get lazy and just paste that because I'm going to have to do that 4 times. At a quick glance, I think that's right. All right, let's go ahead and do the landline. It's almost like somebody should write code to convert from one language to another. Maybe we'll make that your project at some point here. All right, that's extends. That's implements. That guy's a capital S. These guys need to be system out print line. Okay. I'm going to say that that's public so that it stops underlying it because I think it was going to complain at me. Phone number, landline, phone number was in phone. Why are you unhappy with that? Heck if I know why you're unhappy with that. All right, we'll come back to you. All right, let's grab the main and let's move that over. And then we will be ready to start debugging all the crazy. So just paste after the hello world here. It's a lowercase a, I think. And get rid of that hello world. Yeah, that all looks plausible to me. Let's see what I am forgetting. All right. Integer number is too large. Who said anything about an integer? Oh, yeah. So what we have to do here is it assumes that it's an integer unless you put an L at the end. So every time I have one of these really long ones in Java, I gotta stick an L there in order to tell it, no, it's okay, I really mean it to be a long. I declared it as type long, so this is all good. It's just that number's a big number and it's unhappy with it. All right, what else we got? For each, that is totally not how you do things in here. For each should become for, and in becomes a colon. Isn't it awesome that, oh yeah, that's instance of. Isn't it awesome that in some places it is a colon and in other places it is a word? Why are we stopping? Stop. Okay. I need to stop pressing buttons. So how you guys doing? It's fall. It's nice and cool out there. Yeah. I can't declare something of type array list unless I do a type. Because in Java, it cares about the type, which is going to be phone. Cannot find symbol array list. Why can't you find symbol array list? Did I typo it? I did not. Yeah, I need to import it. That's why. Ugh, what What have I done? All of my decisions have gone awry. Yay, the world is great. Okay, so as you can see, there are weird syntactical things, but overall, this exact same code is working. We just had to change around some of the keywords. So both of these examples are posted. Very specifically, I posted them in my REPLs, and let me see what I called them. I called them, well, they will be in my REPLs. Well, I need to give you the link right now, don't I? I don't know what I called them. I've done terrible things. Totally would have told you that I called or that I named them something, and I cannot find them at this moment. There we go. Were they not here a minute ago? All right, so I'm going to drag them into 1322 just so that they're nice and neatly organized for me. I'm going to go in here, and I'm going to pop this one open, and then I'm going to go out and go to my REPLs where I can find the other one, and I'm going to open the Java one. Okay, so if you guys want to pause the video, you can see that is the URL for the Java one. So it's Replit at Enda Sullivan lecture, and this is the one for C#. So hopefully you can grab both of those. You can certainly pause the video and take a look at that. The cool thing about REPL, as I've mentioned before, is you can just grab the code. If you go to that URL and you start typing, it will automatically fork it, and in your REPL, you can play with it. What I mean by that is you can go in and start making changes to the code that I have. You can see there's another block of code down here that I turned off that was allowing me to do this in a more abstract way. You now have those examples. I hope that today's lecture has really finalized everything that there is to know about object-oriented programming in Java. This is the only video of material that I'm posting this week. You are going to get a quiz 4 this week that's going to be posted sometime in the very near future. And so you guys, after you've been through this material, you're ready to take quiz 4, which is going to test you on all the fun things of abstract classes and interfaces and casting and all of that good stuff. The next time that we meet, which will be next week, we are going to start looking at GUIs, and we're going to start doing some GUI implementations. So that's going to be fun. And you should, as I say, be getting your test back at some point in the near future. And if you guys have any questions about any of this material, or you have questions about the test after it's posted, don't ever hesitate to send me an email. I'm always happy. And remember, you can also stop by the office hours at any point if you have questions. So you guys enjoy this wonderful weather, because it is really nice out there. Go run around. There's no pandemic if you're just running up and down your street. So just go run up and down your street or something. Go for a walk. Do something nice. Take care of yourselves. I know that this semester kind of sucks, and it's really hard to get focused on everything. And I know some of you are just freaking out being stuck at home. So I would just encourage you to get out, go for a walk, enjoy the fact that it's a new season, and we're getting through it. We're almost to the halfway point in the class, which is kind of awesome as well. So hopefully you're not drowning. And if you are, send me an email. Let's talk, and we'll figure out what's going on, or pop into the office hours. All right, you guys have a lovely week. Talk to you soon.